We're officially on to Chapter 7. Chapter 7 is exponential and logarithmic functions. I guess the good thing here is that this chapter is so different from everything else that we've done so far that if you kind of missing some things along the way, you have a fresh start here and we'll be able to, you'll be all right. Section 7.1 is exploring exponential models. And in this section, we're going to look at what exponential functions look like, what form they're in, and also some situations that use exponential functions, which is quite a bit. We have quite a bit of situations. First of all, exponential functions are in the form y equals a times b to the x power. And just looking at this form, the biggest thing to notice is that our variable x is the exponent. Where before, like quadratic functions, we had an exponent there, but x was our base, x squared. Polynomials, we had x cubed, x to the fourth, but each time x was the base. Now x is my exponent. And that's going to make my function look pretty different. So let's see what our exponential function looks like. Let's graph y equals 3 to the x power, 3 to the x power. And in order to see what this looks like, let's make a table of values. And I'm just going to use -2, -1, 0, 1, and 2. To figure out my y's, plug in each value for x. So I'd have 3 to the -2nd power. Don't forget what those negative exponents do with flip. So that negative exponent really means 1 over 3 to the 2nd power, which is 1/9. Plug in -1, we'd have 3 to the -1st power. Again, that negative exponent means we have to flip 3 to the 1st power, 1 over 3 to the 1st, which is 1/3. 3 to the 0 power, remember anything to the 0 power is 1. 3 to the 1st power is 3. 3 to the 2nd power is 9. So -2, 1/9, -1, 1/3, 0, 1, 1/3, 2, 9. Those are my points on my graph. So some of these points, like -2, 1/9, it's going to be hard to graph. But I'm just going to put my dot right above the x-axis here. -1, 1/3, a little bit higher up, 0. 0, 1, 1, 3, and 2, 9. And let's think for a second before I connect my dots. So I can see here that my y values keep going up. Let's think about what's happening to my y values over here. If I plug in some more negative values for x, I'm just going to get fractions. If I had -3, my y value would be 1/27. -4 would be 1 over 81. No matter what happens, whatever my x value is, I can have a really, really far negative value for x, and my y value is still going to be 1 over something. So my y values never actually go negative here. And we get closer and closer to the x-axis. Because we get closer and closer to 0, our fraction gets smaller and smaller, but we never actually cross, we never actually hit 0. I guess another way to think about it is if you have 3 to any power, If you have 3 to the any power, are we ever going to equal 0? No, it's not possible. Because if x was 0, 3 to the 0 power is still 1. And again, any negative number is just going to give us a fraction. So since 3 to the x equals 0 is not possible, the function won't cross the x-axis. So that's something to keep in mind as we go through. Since we don't ever actually cross the x-axis, since we never actually cross this line, we have an asymptote. And that's probably a new word for you, asymptote. And an asymptote, that just means it's a line the function approaches. So again, our graph is getting closer and closer and closer to this line, but it's never actually going to hit. All right. Now let's go back and talk a little bit more about our exponential form for a second here. If you look at my exponential form, y equals ab to the x power, and compare it to this, y equals 3 to the x power, think about what a is. Well, I don't have a number written here, so it's really like 1 times 3 to the x. I'm going to rewrite that down here. Y equals 1 times 3 to the x power. And let's talk about what each part of this function does. Do you see where we have a 1 in our graph? That's our y-intercept. So our a value in exponential form, a tells us the y-intercept. This b value tells us our rate of change. B is the rate of change. And if you look at our table here, it's a little bit harder to see with our negative values for x, but look at our positive values. 1, 3, 9. Do you see what's happening? Each y value we multiply by 3. So 1/3 times 3 is 1, times 3 is 3, times 3 is 9. B is our rate of change. That's what we multiply by each time with exponential functions. And our b value, just kind of in general, we have exponential growth. What we say is exponential growth. If b is greater than 1, and we have exponential decay if b is less than 1, but there's one other condition. B has to be a positive number. So b has to be between 0 and 1. Okay, so that's a lot of information about exponential functions here on our exponential form, but this is all really good setup as we go throughout our chapter.